We can look at some graphs, and these graphs are a bit busy, but what these graphs express are the stock prices for which early exercise is optimal as a function of the volatility. So let's do one example. First of all, this is a 5-year call option, has a strike of $100. We have R and delta are the same, so they cancel. The interest that we earn on K by holding it is pretty much the same as the rate, at least, that we would earn on dividends from the stock. So let's look at one example, and this is where sigma is 10%, relatively low volatility. So what you'll notice is that the optimal value looks to be about $130. It's saying that in order for you to exercise at time zero, you have a 5-year American option on this stock. In order for the exercise value to exceed the value of future exercise opportunities, the value of that stock needs to be about $130. Then you will get $30 of profit by exercising. And what it's saying is, otherwise, the time value of the option, the value of waiting to exercise, is more. And you should, so if the stock price is 125, you should wait. But you can see that as you move through time, the level of stock prices for which you should exercise very, very slowly drops and gets closer and closer to 100. In other words, when you get to the point where you're 5 minutes before expiry, if you're in the money, it's probably logical to exercise. Notice that for higher volatilities, 30% or 50%, that stock prices have to be much higher in order for you to be willing to forego future opportunity. Because remember, when sigma is high, there are two components to it. One is that the stock has a more volatility, so it's more likely that it'll reach a much higher point and the call will have much more value than it has today. There's also some risk associated with the insurance of the call option that the stock price will fall and you'll be sorry you exercised early. But in general, we can see that the effect of increasing sigma is to say the value of future exercise is more, and therefore, in order for you to exercise now, it has to be more in the money. So for example, where a 10% volatility 5-year option, you might exercise when you get to be about $130. If that were a 30% volatility, same option, if you expected 30% volatility in stock prices, you would not exercise until prices were, looks like, about $220. That just tells you that the additional value, or the value of future exercise, is about $120. That's what it's telling you. It's saying that in order to exercise today, you have to profit $120. That means that the value of all future exercises is pretty close to $120. If I had a 50% volatility priced in this option, I wouldn't exercise until prices were somewhere around $360. Again, what's that a measure of? It's a measure that in order to exercise, and I would make a $260 profit, that $260 profit will pay me for what I give up by foregoing the opportunities of exercising in the future. You'll notice exactly the same pattern with puts, but it goes up, of course. Namely that in the call situation, high prices meant deep in the money. Here, low prices mean deep in the money. So here again, it's a $100 strike, and it's saying for a 50, notice now the 50% volatility is at the bottom. It's saying that if you have a put option with a 50% vol, in order for you to exercise today, with 5 years left on it, you should be exercising at a price of around $28. That means you would have a profit of around $72, and that tells you that the value of future exercise is worth about $72. So in order for you to give that up, you have to be able to make about $72 now. And as you move through time, the price at which it's optimal to exercise goes up, logically, and gets closer and closer to 100. For lower volatilities, you're not giving up as much opportunity by exercising early, so you don't have to make as much money on the early exercise. Now you'll notice that in both of these graphs, the actual prices look like a sawtooth pattern. They go up and down. And this is because this was an option that I believe was priced with 100 steps. H is equal to 1 over 100. So the author created a binomial lattice with 500 steps. And what happens in a binomial lattice with 500 steps is where you look at early exercise, as you move through time, you will not have nice continuous prices. I can show you, imagine a lattice, a binomial lattice. And imagine that you might exercise the call here, 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 and then maybe here. So because of the discretization of stock prices, when I looked at this time, I would pick up this price. When I looked at this time, I would pick up this price, and then it would be lower, of course. And in here, I would pick up a lower price. So you can see that, and maybe in the next period, maybe this was the last price, these two prices. So you can see that there can be a tendency for the prices at which we exercise to go up and down simply because of the discretization, and that it's possible that because of that we have these gaps and it looks like the sawtooth pattern. On the other hand, if we let H be smaller and smaller and smaller, these so-called exercise boundaries would look increasingly smooth, and you would have a nice smooth line represented by each of these volatilities.